Right, what we're doing today is a lot like what you did in the lab. We're going to be using an outside triangle and an inside triangle to solve for certain things here. We're not solving for the angle now. I just wanted y'all to know how to do that. So it'll give you a question. You'll need to draw the triangle, including the inside triangle. That's what it means by draw both triangles here. Here we go. I'm going to draw my triangle. It says a phone that was pushed up a 10-degree incline has a mass of 0.4 keys. So I'll do my best to draw a 10-degree incline here. Let's see. 10 degree? Here we go. 10-degree incline. It helps to draw a big triangle. And if it is a really small number of degrees, you might kind of fudge that a little bit and say, make it a little greater slope than it is, because it makes it kind of difficult to draw what you want over here. Okay, so I've got my triangle, and I'll put my mass on there before I finish drawing my inside triangle. There we go, got my mass right there. And that's all it gives us. So we need to calculate the weight, and then it's asking us to calculate the adjacent side of that triangle. Now, when you draw an inside triangle, it is geometrically similar to this other triangle. So, oh, look at that. How about that? That's good to know. Well, so those two angles are the same as each other. So if this is 10 degrees, then that angle is 10 degrees. And because that angle's there, let's see, this is our right angle. So this is our hypotenuse side, and this is our adjacent side. Our hypotenuse has to be where the weight goes, because the biggest component of the weight will go straight down. The weight into the slope isn't quite straight down, so it's not quite all the weight, and the force of the weight that's pushing this down the slope is just a little bit of it, because this isn't straight down at all. So let's calculate the weight first. Weight's a force. We're using F equals ma. I'll say Fg because it's weight. Because weight's because of gravity, we'll use A equals negative 9.81, and we'll use the mass that we're given there. So you got 0.4 kilograms times negative 9.81. And that makes our weight negative 3.924. There we go. Is that really a 9 though? Yes, it is. That's in newtons. That's not a W. That's an F. There we go. So this number is our hypotenuse side. And now we gotta find the adjacent side. We've got the hypotenuse, we're looking for the adjacent, and we have our angle here. So this is all in pursuit of finding out what the normal force is. Normally, normal force would be just, if the weight's negative 3.9, normal force would be positive 3.9, but that's only when it's on a flat surface. So if weight's negative 3.9, normal force would be positive 3.9. But normal force is this pushing into the surface and the surface pushing out. It's not the surface pushing up, it's the surface pushing out. And when the surface is flat, up is the same as out, but when it's tilted, it's not. So that's why we got to do trigonometry to figure out what the normal force is in this situation. So if we've got h, 3.9, we're looking for a. That means a and h go with c over here, so we'll use cosine. Let's see. Cosine of theta equals adjacent over hypotenuse. And, I better give myself a little more room there. Here, I'll come over here. Theta is 10 degrees. Make sure your calculator's in degrees. And that's in the way. Adjacent is what we're looking for, and hypotenuse is the weight there, 3.9. Whatever, 3.924 newtons. I wanted to say equals adjacent. I'm going to move that over here just a little bit. I wanted to say equals adjacent, and it says adjacent divided by 3.9, so I'll do the opposite to make it cancel and multiply by 3.9. So there's one on top, one on bottom. They canceled. It says equals adjacent on the right, and I just got to put this in the calculator, and I just did this, and I don't remember what it is. That's 3.86. 3.86. So over here, our force, that's newtons, because my other one was newtons. This ends up being 3.86 newtons, and that's all the trigonometry we have to do. We just do it once. We figure out the weight, find the adjacent side. It's pushing into the slope with 3.86 down, so normal force then is 3.86 up. And there we go. I think your questions ask you for this one, for what the adjacent side is, and then it asks you for normal force, but I'm not sure. But you need a diagram like these. I thought drawing my triangle over there would make it a little neater, but not so. It's hard to draw on these inside triangles. I recommend making it bigger here. So please start this one. It's called trig and normal force. Oh yes, thanks for reminding me. Let me stop the video first.